Alright, so I'm going to show you how we do one of these problems with limiting reagents, and this is where we have reagents, aluminum oxide and iron, and we have a certain amount of each, and we want to figure out if we have that certain amount of each, how much of this iron oxide can we produce, and this product. And what can help us in this is the mole ratios, because we know these are set things. Now the grams of each might not be. Sometimes they kind of match up, sometimes they don't. So whenever we're doing a problem like this, one of the most important things to do is to make sure it's balanced. And then the next thing we do is we go through this mole equation where we start off with grams, and we know these are the two reactants, aluminum oxide right here, and then iron right here. And we have a certain amount of each, 25.4 of this, 10.2 of this. And then we're going to take these grams and we're going to convert them into moles by using the ratio this way. Because if you look, we cancel the grams here and we end up with moles. Then we know how many moles we have. That's useful because we know the mole ratio. The grams might not be so helpful, but the mole ratio is always the same. It's the law of conservation of matter or mass. So then we take this mole ratio, make sure we're crossing them so we can cross out, and we use it, and then we calculate the math across, and then we figure out how much we have of each. You can see here I've done the math already. This is 25.4. If you multiply by 1, by 3, by this 231.4, divided by the things on the bottom, you get 43.2 grams of iron oxide. So if we have this much aluminum oxide, we can produce this much iron oxide. But then the iron, we have 10.2 grams of iron. Again, do the same thing we did on the top and the bottom. And then we multiply the numbers across. And again, the main thing we're looking at here is we're changing this iron to moles. And then we're using the mole ratio. And then we take that mole ratio we figured out. And then we convert that into grams. So then if we go 10.2 times 3 times 231 divided by 55.8 divided by 9, we will have 14.1 grams of iron oxide. So with aluminum oxide we can produce 43, about a little more, and then we can produce right around 14 grams. So this is the limiter right here. Iron is the limiter because it produces the least. So that means if we have this much aluminum oxide, we're going to have excess. So then how do we figure out exactly how much we need or how much extra we will have left? Well, that's the next part. So let me erase this stuff here. And we'll pull this down. It should be on your sheet. And I did the same thing here. I'm going to move this up. Okay. You might see the numbers change a little bit. Don't worry about it. And then go back to this, we look at this, do the same thing, but we do it the opposite. So on the top here we started with the reactants and went across. Don't worry about these 4, 9, 3, and 8. I'm just, I can move them up if you want, but I won't. So instead of starting with the reactants, now we know how much we're going to produce, and we see, well, if we produce this much, how much aluminum oxide do we need? Because we're going to do the same thing. We're going to take the grams of this, convert it into moles, use the mole ratio, and then convert it back to grams in the third little multiplier. So if you do the math, 14.1 times 4 times 102 divided by 231 by 3, and we're going to get a number. Let's do it, because I haven't done it yet. And this will tell us how much we'll actually use. So we've got 14.1. Multiply it by 4, multiply it by 102, and we get that. Then we divide by 231.4, then we divide by 3, and that'll be 8.29. So if you type that in, 0.29. So this stuff right here, Al2O3. Get rid of that line. Okay. So that's how much we're going to use. So then if we wanted to know how much excess is left over, we just take 25.4, we'll do that one more time. this out of the way. Go back. 25.4 minus 8.29 with 17.1 in excess. We could then type that in. So if we just had more of this, we could probably produce, if we had this same amount, we could probably produce, again, another 14. Okay, so that's that. And then the last question is percent yield. So I'm going to move some of this stuff down. Don't let it freak you out. And move this down. And this is what is the percent yield. So if I have 13.5 grams is produced, what is the percent yield? And percent yield is just going to be this right here divided by the theoretical yield. And the theoretical yield is what we said we could produce. And that is, if you remember, it's 14.1 grams, this one right here. That's the limiter. That's how much we could produce if we just took this. So if we brought this down, it would just be, let's go down here. Yep. I have to pull this down a little bit. Okay, let's go down a little further. So then if we did 13.5, we divide it by 14.1, then we'd multiply it by 100, and that will give us, so if you got our calculator again, if we actually get 13.5, we divide by 14.1, get equals, we times that by 100, that'll give us a percent, 95.7%. It's pretty good. And that's what you should have got for this problem. I hope it turned out for you. If you have any questions, you can always ask me, email me. Let me know. I don't think I made a mistake on this. I looked at it over and over and over again. And that's it. Hopefully that worked for you. Make sure you complete the worksheets you've been assigned, and email me any questions you have. We're going to have a test on Wednesday or Thursday. Probably Thursday will be fine. And let me know if you have any questions.